about the V8 GPU. And before I say anything else, I would like to ask a question and really involve the audience a little bit. So, how many of you know that the V8 GPU is actually a separate product? So, it's done by different people? Ah, okay. It's done by different people, and it's really different from the CPU. So, how many people do you know? I'd like to see hands here. Okay, so 1 or 2 people. Okay, so that's not too many people. So today I'm gonna attempt to explain how it works and why that it's different, because most people don't understand that it's different and the way you use it is the same as the CPU, but the results you get are slightly different. Now, this is a short overview of the topics that I'm going to cover, and on the right you can see renders that are done with the GPU. They're done by the bar team, some of our very cool clients, and what they do is they use the GPU for basically their production, so it can be used. We have examples here that you can get pretty good results with the GPU, and oh, it looks a little jagged from my point of view. It doesn't matter. Okay, so since our development is feedback driven, we have taken their feedback so we can make the V8 GPU as good as possible. So one thing that we have developed for them and for everybody else, because we implemented that in our public releases, is the adaptive sampling. And Jana has talked to you a little bit about that. I'm going to talk as well. And basically what adaptive sampling is when you have many lights in your scene and enable adaptive sampling, the lights that are far away are going to get less samples, so everything, even though it looks the same, it renders much more quickly. Now, so what are the main differences between the CPU and the GPU? Well, obviously there are very different pieces of hardware. Now, the CPU is not only visually different, but the whole architecture is different, and the code it runs on is different. So it should come to no surprise to anyone that the results you get from the CPU are slightly different from the results that you get with the GPU. It's just the way it is. That's how they work. So one thing that you should take away from this is that even though the workflow is the same, so no matter if you use the GPU or the CPU, we've made it so it looks the same, but the results you get are different because different hardware is actually calculating your image. So, and we have here a short demonstration. So this is the CPU firing each pixel one after the other, and this is the GPU that's firing every single pixel at the same time. And we can see that in slow motion, and that's how they're different. The CPU is basically calculating each pixel one after the other, while the GPU is using something that is called parallel processing, which means that every single pixel is going to be calculated at the same time, more or less. So, which one to choose? That's a question that I hear a lot, and people ask me which is better, and there's really no right or wrong answer here. Nothing that I say about the GPU is better than the CPU, for example. It all depends on what you're doing. So I can tell you that people that work in the automotive and product design prefer the GPU because it's faster and it updates very quickly. So if you want to work in that field, maybe the GPU is the right answer for you. Now, what I can tell you right now, and this is very important, I would like everybody here to hear this and understand this, is that the GPU, if, let's say, you start working on it, so you start your project on the GPU, stick with it all the way to the end. Don't go switching to using the CPU, because then you get different results, and then you might not like the results that you get with the CPU, and you'll be like, oh dear, what did I do? I messed up my project. So please choose one and stick with it. If you like to work on the CPU, stick to it all the way to the end. And the same goes for the GPU as well. But I can almost hear a question coming up, and that is, why can't we use both? Why can we render on both the CPU and the GPU simultaneously? Well, I'm very happy to say that in version 3.6, we introduced something that is called hybrid rendering. And what that enables you to do is you can use both the CPU and the GPU to calculate your image. Now, there are lots of misconceptions about the hybrid rendering. People think that people don't really know how it works, so I'm here to explain. So basically, the hybrid rendering is an option that you can find within the V-Ray GPU rendering engine. So the V-Ray GPU is doing the primary calculations, so it's doing the bulk of the work, and the CPU is merely helping it. That's important for you to understand. People think it's the other way around. People think that the CPU is calculating the image, and then the GPU is merely helping it. But it's not that way. So, I'm going to repeat it again, just to make sure that everybody understands, because people don't understand. The GPU is the primary force behind your rendering, and the CPU is just helping it. And what we did was basically we translated the CUDA code, so the code that runs on the CPU, on the GPU, we translated it so the CPU can understand it and calculate it. And now the benefit that you get is that the image looks the same on both the CPU and the GPU, and they can actually render it simultaneously. We did it for you guys, so now you don't need to say, oh, why can't I use both? Well, now you can. With version 3.6, please upgrade to the newest version, and you'll be able to render your image on both the CPU and GPU. The result will be the same on both hardware, and some other awesome thing that you have is that the CPU, the RAM that's available to the CPU, can now be used for calculating the GPU rendering. So you get more memory that way. You also get a speed improvement. And I have a video here that shows that. So we enable the GPU rendering engine. We turn on the CPU, C++. And then when we render, the image on the left is without hybrid rendering, and the image on the right is with hybrid rendering. And as you can see, we almost cut the rendering time in half. Well, almost half. But it's quite a speed up without really anything. Just you click one checkbox and you get twice as fast render. We also implemented something that is called NVLink. This was developed by NVIDIA. This is an actual hardware that you have to buy with your graphics cards. So what NVLink is, by the way, does anyone know what NVLink is? Have you heard about it? Hands again? Hands? No? You don't? Only one person? Okay. Don't tell everybody. I would like to tell them. Okay. So what the NVLink is a high-speed connection between graphics cards. So in the past, the connection wasn't very fast, so graphics cards couldn't communicate and couldn't share memory. But now, with this fast connection, you can share memory, which means that if you don't have enough memory to render your image, with shared memory, you can. And I have a video for that as well. And I believe we were the first ones to implement the NVLink in our rendering engine. So this is without the NVLink, and as you can see, we will get an error. Oh, unable to allocate enough memory. But when we enable the NVLink, which you don't really see, but when we enable the second graphics card, now you will be able to render because you have enough memory, because the two graphics cards share the load. Now, in the past, it didn't really matter how many graphics cards you had. Even if you have 100 cards, you couldn't render this image because they can't share memory. So you basically have only one card worth of memory. And we also have made lots of other improvements to memory, because as people know, probably the biggest stepping stone in GPU rendering is the memory that's available, because graphics cards, especially in the past, have very little memory. And it wasn't enough for people to render their image. And that's why we developed things like the on-demand mapping, which solves that problem. And how do you set the V-Ray GPU? Well, the V-Ray GPU comes in two modes. One is interactive and one is progressive. The interactive mode is best for loop development. So while you're still working and trying to figure out how to make your scene, it's best to use the interactive render. But when you're done and want to render your finished scene, you should switch to the production GPU, and you get a lot more options that way. I'm going to show you in a few seconds how you can do that. And like I said, this is a scene from the party. I would like to thank them. I doubt that they're listening, but I would like to thank them for providing the scene for us. And I'm going to use the scene to explain a few things. And they have made a video that we can watch. We don't have sound, but still, we can watch it. Okay, so that was it. And this was all done with the V8 GPU. And by the way, these are all renders. These are raw renders. No Photoshop, no nuke, no nothing. This is how it looks straight from Max. So let's first talk about the camera. So many people ask me, how do I place my camera? How do I place my camera so everything looks interesting and natural and real and so on and so forth? Now, there are some people who have a feel for this, so they're able just by looking at the image to kind of know where to place the camera. But for other people, there are rules that they can follow. And one very, very famous rule that probably most of you know is the rule of thirds. What you do is you basically divide your screen in three equal parts, both horizontally and vertically, and then you get dividing lines. And where those dividing lines meet, that's where you place your object. So if you can see here, this dividing line is a place that you might want to place your objects, your hero objects, and a hero object is basically an object of interest. And in this case, it's this bowl here that you see. So it's roughly placed in the middle of that dividing line, so it's very well placed. And then we have this leaf here, and if you notice, it's the only one that it's in focus, and it's right next. Oh, I messed things up a little bit, but yeah, it's right next to the dividing line, which means that it's also something of interest. And you think that this was done, this is just a coincidence, but it wasn't. So it was by design. People actually think of dividing their screens and how to place their objects in a way that works. Now, we've also seen that in the animation, the camera is moving. So how do you make your camera to move in a very natural way? Well, one way you can try it is to make some kind of a rig that is very similar to the way you move the camera in the real world. Sorry. People have rigs that move real cameras, so if you think of how they do it, it's not very simple. You have to have some kind of machinery that moves the camera. And if you think that way in CG, your camera will look much more naturally because people are used to seeing that kind of stuff. And I have a video here that shows, this is the scene from the Bartley, and this is the camera movement. And I can show you how this looks. And this is just one controller. It's a custom controller that moves the camera. This is the camera itself, and you can see the trajectory that it goes. And then we have different options, and these are scripted, so you don't have these with Max. And we have different options for heading, pitch, bank, track, and if you know cameras, you know that these are actual terms that are used by cinematographers, let's say, that move real cameras. So that's one way you can make your camera movement look more natural, because that's how people do it in the real world. Now, another thing is lighting. And when I got the scene from the body, I was really impressed. And can anyone guess how many lights we have in the scene? Just numbers. I would like to see 2 lights. One? One light? So the entire video is made with 1 light? Yeah or no? The entire thing that we saw is made with only 1 light, or 2 lights. Okay. I was really impressed, and somebody said 1, and whoever said 1 was right, because the entire thing is made with only 1 light. And it's a very simple light. It's actually a V-Ray planar light that has a softbox texture in the texture slot and a little bit of directionality. And that's it. This light works for every single camera. So we have 5 cameras and we have only 1 light. So it's kind of ingenious, don't you think? Well, people think that it's very easy to come up with this. People think that it's, you place 1 light and everything works. Well, it doesn't work that way. The guys who are actually making the light, and this is the light that's used, had some trouble, I think, because they made lots of other lights that I'm going to show you right now. They're hidden, and I'm going to unhide them for you. So these are all the other lights that they made, and they're probably just lights that were in progress. So people just make lights, and they don't like the results, so they hide them, right? So now I'm going to show you what the render results look from different lights. So I'm going to start the V-Ray interactive render, go to the settings, switch to active shade, and that's how it's called in Max, and then to V-Ray RT. And in the V-Ray RT settings, as you can see, there are not many settings. You can choose the CUDA, which means the graphics card, and I'm going to make a few changes to the settings just to match the Varti settings here. And then I'm going to click render, and that's it. It's very simple to set up, as you can see. And this is how it looks. This is the final result, but now I'm going to show you how it looked with some of the lights that were work in progress. So I'm going to disable the one light that it's used and activate all the other lights. Let's see what the result will be. And I can't say that it's a worse result, but I think I like the one light setup more. And if I disable some of the other lights, I'm going to get a different result. So that's a good way to really think of different ways how you can render your image. You just make some lights, place them really anywhere, and see what kind of results you get. Now, at some point, you get a lot of lights in your scene, so how do you manage that? Well, what I found is that you can basically turn off all the lights in the scene and start turning them on back on, one by one. And that way you can see what each light is doing, and you can make changes or delete lights, or let's say you want something else. You can do it that way. So that's a good way to optimize your scene, and that's what the Varti did, and they did the final thing with only one light. And then we have materials, and I'm going to talk about only about this material, the steel for the knife. And this is actually a real material. It's called Damascus steel. I don't know if you know what that material is. I'm going to explain. It's basically a material that is combined several different types of steel into one type of steel. Basically, you fold them together and you get sort of like rings, basically. Because when you grind the steel, you get the different types of steel exposed, and then when you etch them, the steel oxidizes in a different way, and you get these lines that you see here. And the way this can be done in 3D is just with procedural maps, just noises and ramps. That's it. So it's very simple. The shading network looks a little bit complicated. I'm going to pick the material right now. So you can see the shading network. It looks complicated, but it really isn't. It's just, like I said, noises and gradient ramps. And this is the noise. It's very fine, so you probably won't be able to see it. But then you plug the noise into a gradient ramp, into a mapped mode. And then with the gradient ramp that you're going to see here, you make those lines that you see there. So basically you make the rings to correspond with the real steel. And that's how it's made. And then you make a bump map, a few masks for the edge, so the steel is not visible, the lines are not visible near the edge. And basically you get the final result. But this is all done procedurally. So you can change anything in progress. And as you can see, the V-Ray GPU is very quick to update here, and that's why people love it for this sort of work. And then we have rendering. Now, up to this point, we have been using the interactive GPU, which means that we were still in progress. We were still doing the work in progress, but now that we're done, we can switch to the production GPU, and I have a video here that shows how to switch to the production. You basically pick production mode, then go and pick the V-Ray RT, and in the V-Ray RT, you will find the GPU mode, which will enable the V-Ray GPU. And then I'll just have trace depth. I increase the trace depth because that's what the Varti did. And here we have lots more options for global illumination, light cache, for environment, color mapping, and so on. Basically, everything that you will find in the CPU-based rendering engine. And then we click render, and that's it. Here we'll see V-Ray make a light cache calculation, which will enable you to see your scene very quickly. And that's it. That's it. It's that simple. You just click render and everything works. So, next we're going to talk about how you can speed up your rendering. And Jan has told you about this, but I'm going to repeat because I like repeating things and bore you to death. But no, one way, you really should learn when to clap. You know, that wasn't the right moment. Yeah. Okay, so one way you can, there are all sorts of ways you can improve the rendering speed, but probably the coolest way is by using the V-Ray denoiser, and this is just the result that you can get with a V-Ray denoiser. On the left you see the denoised image, and on the right you see the image with the noise still in it. So basically what the denoiser does is it uses several rendering layers to target the noise and then remove it from the image while keeping the textured detail. And this works also in animation as well, as you can see here. Basically what the V-Ray denoiser does is it looks to the next frame so it can figure out how to denoise the current frame. And we call that frame blending, but what it does, it simply wants to make sure that it's not going to have any jumps between frames because the denoise is different. And yeah, it's hard to see here, but it's working. It's doing a pretty good job removing the noise, as you saw in the close-up version. And this is just a table with different pieces of hardware and how they compare to each other while using the V-Ray denoiser. And the V-Ray denoiser is primarily used with the GPU, so it's calculated on the GPU because it's much faster that way. You can still use it with the CPU, but the GPU, like I said, is faster. And this is the V-Ray GPU evolution. So as you can see, we've made major strides from version 3.0 to 3.6. So all of this was done for you, and it was done basically for free, because if you have a license for the 3.0 version, then you can download the 3.6 and it's free of charge. So all of this, and this is, by the way, just the major updates to the V-Ray GPU. The list with bug fixes and minor changes is practically a mile long. So the people in our team have done a lot of changes to it, and they made it better. With every single release, it's getting much better. So, and we also have some unique features, like I said, adaptive sampling, which will speed up your renders quite a bit, renders with lots of lights in them. Then we have the render mask, and the render mask is basically a way to render a single object. Let's say you have an object of interest, you select it, and V-Ray will only render that object and nothing else. We have the V-Ray clipper, so let's say you have a car engine, and you would like to see the pistons inside. Then you can clip the geometry with the V-Ray clipper without doing any modeling, excuse me, without doing any additional modeling, and the clipper will let you see the pistons inside. It will clip the block, the engine, basically. And then we have aerial perspective, which is probably the coolest way to make fog. It's very fast to calculate. In the future, we are also going to implement the environment fog for those who want to use that. We also support light directionality, which we saw the part he used in their scene. And we also saw, we also support forest color. And forest color is something found in the forest pack. I don't know if you know this. Many people wanted the forest color, so we made them for them. We made them support it. So the forest color basically lets you make random colors for all the forest objects, which is probably the coolest way. Let's say you have a forest, every tree will be slightly different from the other. And then we have the V-Ray benchmark, and I'm sure that you've seen the V-Ray benchmark in action on the computers outside, which is probably the best way to find which computer is going to work best with V-Ray. There's a full database with computers and how they compare to each other. And with the V-Ray benchmark, you get two scenes. One is CPU-based and the other is GPU-based, so you can compare them independently. So, a short summary. The V8 GPU is very powerful for rendering. We see more and more people switch to the V8 GPU rendering, especially very big companies switch to it. And like I said, it's very powerful for automotive and product design, also for interior rendering as well. It's very fast. It's constantly evolving. We're always working on it and trying to improve it. We also have free multi-level support, which means that if you have any questions, you can go either to our website or to a forum and ask us basically anything that you like. We're also increasing the number of video tutorials, and we're going to have a very cool stuff for you in the future. And these are just some links to our website. You can go there and download all sorts of stuff. We also have the docs.kiosco.com, where you can find information about anything that you want related to our products, and of course our YouTube channel, where you can find all the videos that we upload. And that's it. Thank you for watching. If you have any questions, you can ask me now, or when I get outside, I'll be outside. And people have asked me lots of questions so far, so I would like to thank you for that.